TypeScript is basically that one protective friend who refuses to let you leave the house without your keys, your wallet, and your dignity. But sometimes being safe makes our code look like a literal staircase of if statements. We've all been there, checking if a user exists, then if they are logged in, then if they have an admin role, and suddenly your actual logic is buried 5 levels deep in a nesting doll of doom. Today, I am going to show you the linear validation pattern. We are going to stop asking TypeScript for permission and start asserting our dominance. Usually, we use type guards. They're great. They return a boolean, but they force us into a corner. If the check passes, we do something inside the block. If it doesn't, well, we're stuck in an else or we just keep nesting. It's like a bouncer at a club who asks for your ID, then asks for your ticket, then asks for your wipe check, but makes you stand in a different tiny room for every question. Enter assertion functions. These are the VIP pass of TypeScript. Instead of returning true or false, these functions say, look, if this isn't true, I'm going to throw a tantrum, an error. But if I don't complain, you can assume everything is fine for the rest of the file. It keeps your code flat, readable, and beautiful. Alright, so for this demo, we're going to build a tiny validation app using TypeScript Assertion Functions. The idea is simple. The user will paste some JSON into a text area here, we'll parse it, then validate it step by step using assertion functions, and if everything is valid, we'll display a success message with the user information, otherwise we'll throw a clear validation error. The important part here is that the incoming data is completely unknown. TypeScript does not trust it initially, so instead of using unsafe typecasting, we'll progressively validate the data in a clean, linear flow. That's the entire idea behind the linear validation pattern. This pattern becomes incredibly useful when working with API responses, form data, local storage, URL params, basically anything coming from the outside world. Here we've got 3 main files, one HTML file, index.html, then our style file, styles.css, and the main part is logic.ts, which will be then compiled to this logic.js. Okay. Let's start simple. I'm going to create a basic user type with a name and an email. So type user, an object with a name which is of type string, and also an email which is also in string. Nothing fancy here. This is just a shape we eventually want our data to have. Here comes our first assertion function. We're going to check whether this JSON input here is actually an object, a JavaScript object. Let's start writing the first assertion function. Assert is object. The name, of course, is up to you. Then we'll receive the value, which is of type unknown because we don't know in advance what the user is going to paste there or type there. And then here is the important part. We need this function to assert if this value is a record of string and unknown. Let me also zoom out a little. Here is the important part. So need to remove this semicolon and then start implementing the body of this function. What we want to do here is to check if type of value is an object. So if it's not an object or not null, in case we have an empty input, then we want this function to throw an error, throw new error, and then of course we can also pass a message to this value is not an object. Cool. Notice that the input here is unknown because external data should never be trusted. This is the magic part. We are basically telling TypeScript if this function finishes successfully, you can now treat this value as an object. Inside the function, we do a real runtime check because TypeScript types disappear at runtime. So if the value is not actually an object, we throw an error immediately. Very dramatic, very defensive. It also worth mentioning that we asserted that the value is a record of string and unknown because here we want to ensure that this value is actually an object. Next, let's validate the name. At this point, TypeScript already knows this is an object, but it still doesn't know whether a name property exists. So we need another assertion function. Assert has name, again takes a parameter obj because at this point certain that this is an object which is of type record, string, and unknown. Asserts this parameter is the record of string and unknown, and it has a name which is of type string. So after this assertion succeeds, TypeScript understands that the object definitely contains a string name. This little ampersand means we're combining types together. So now the object is still an object and also it has a name property. Why we combine these two? Because this object can contain properties other than name, but we need to ensure that it definitely has this name property. Then check if type of object.name string. So if it's not a string, we can also add another check. This object.name.trim is empty. So if the name is an empty string, then again we need to throw an error. And we add a message invalid or missing name. So after this assertion succeeds, TypeScript understands that the object definitely contains a string name. Now we'll do the same thing for the email, and this is where the linear validation pattern starts to shine. We validate step by step in a clean linear flow. So here I just copy these lines and paste it here. Assert has email, and instead of name property, now we check whether this email exists, and also we need to change these lines as well. Valid or missing email. Perfect. Of course, here we can alternatively check if this email includes the @ symbol, which makes more sense for an email input. Now let's put everything together. We've implemented the assertion functions. Now it's time to implement the validation function. Here, the right function validate user, which takes parameter of type unknown and progressively validates it. Watch how readable this becomes. I just call the functions that we've already implemented. First, we need to assert if it's an object, then we do the same for the name property, and finally, email. And that's it. Also, put this comment here, because at this point, TypeScript is 100% sure that this input is an object and also has name and email properties. So we can safely return name data.name, so email data.email. Of course, we can also make that shorter by returning data. I also add that and comment that out, so we can also see we can directly return the data as well. And I save that. That's the linear validation pattern, known as that chaos no validation spaghetti. And now TypeScript fully understands the structure, so returning the final user object becomes completely type safe. And finally, the UI hook. Here, we need to access our input, the text area, also the validate button, and finally, this part for showing the result. So let's start with the input, const input, and use the good old document.getElement by ID, and I pass the ID of that text area, JSON input, as HTML text area element, to be very explicit about that. If we go to our HTML file, you can also check if the ID name is correct, JSON input, for the text area, and for the button we have a validate btn and result as the ID of our div. So let me copy and paste this line. We've got our button. The ID is validate btn, and it's not text area, it's a button. Also, the result div ID is result, and it's HTML div element. Next, we want to add the click event listener. Button dot add event listener. Whenever the user clicked this button, we need to execute that validate function that we already implemented. First of all, we can empty the text area, set the text content to empty string, and then, this is important, we need a try catch block, because if the user enters an invalid JSON input, we should take care of that in the catch block. In the try block, first of all, we need to parse that JSON input. I declare a variable parsed JSON.parse, and we need to pass the value of that text area, so the text that the user enters here. Then we need to set the user variable. So we validate the user using the function, and we pass this parsed variable to that, which is hopefully an object, a valid JavaScript object here. If it succeeds, let's reflect that in the result div. We change the text content of that to this text. I use backticks valid user dot name, then in parentheses user dot email. Also, you can add a CSS class, result dot class name. Success. If we go to our style file here, I have added success class where we change the background and the foreground colors. So let's go back, and if it's not successful, we will make it into the catch block. Result dot text content, again string literals, error dot message, and also the CSS class should be added. Result dot class name, error. Okay, let's run our app using the tsc command and see the result. Okay, here first I enter an invalid JSON, so something like this, and yeah, you see that we got an error. Then something that does not include, for example, name, so age 30, of course a valid JSON and a valid JavaScript object. Yeah, you see invalid or missing name. Then let me fix that by adding name, for example David, and this time you see that it complains that the email is invalid or missing, so I also add the email. And first let me enter an invalid email, david.com, of course inside double quotes, and it says valid user, which is apparently not correct. Let me check. Yeah, we need to add this exclamation mark to flip the condition, and then let me save it again. Okay, now we get the correct error message, invalid or missing email. Then if I add David at example.com, now it's working as it should. This is the linear validation pattern. Assert your conditions at the top, execute your logic at the bottom. It makes your code look like a recipe instead of a choose your own adventure novel. Plus, if something goes wrong, you get a clear error message instead of a silent failure or a cannot read properties of undefined nightmare. You've just leveled up your TypeScript game. No more nesting, no more pyramids, just clean, assertive code. If you found this helpful, hit that like button. It feeds the algorithm gods. And subscribe. And let me know in the comments, are you a nested if defender or are you ready to join the assertion army? Until next time, keep coding, keep learning, and as always, stay awesome.